Hello everyone. These are the last two topics of the section 2.5. Here in the first topic, we're going to check how do we identify whether the given two functions are inverses of each other or not. So let's say we have given two functions f and g. Then if these two functions are inverses of each other, then these two conditions should satisfy. So that means the composition g of f should equals x for all the x in the domain of f, and the composition f and g should equals x for all the x in the domain of g. So you can see that here the same composition things that we discussed before. This is like plugging the f function into g, and this is plugging g function into f. So in both cases, if we get x for all the x in the domain of f and domain of g, so that means these two functions are inverses of each other. So let's look at this example. Here we have a function f, x to the power 3 minus 1, and gx function is the third root of x plus 1. So this is in the radical notation, or you can write it in the exponential notation of this form, x plus 1 to the power 1/3. Now I'm considering the g of f of x. So this is the composition g and f. So that means I'm plugging f function into g. I know how g works. G adds 1 to whatever the input and take the third root of it. So here I'm plugging f, so it is adding 1 to f and then take the third root of x, third root of this term. Now, but I know what is my f is. F is x to the power 3 minus 1, 3 minus 1. So that means x to the power 3 minus 1, and here we have a plus 1, so that comes here plus 1. So now this negative 1 and this positive 1 cancels out. We get x to the power 3 to the power 1/3. So then here, when you simplify the exponential, this is a power of a power. These two exponentials cancels out. This becomes a multiplication, 3 times 1 over 3. So then 3 divided by 3 is 1, so we get x1 here. So in one side we are getting x. So this g composition of fx is always x for all the x in the domain of f. So one condition is satisfied. So you can do the same thing to the other way around. So here I'm plugging g function into f. What is f doing? F takes the third power of that and subtract 1. So here third power of g, because g is the one that we are plugging, and subtract 1. What is g? G is x plus 1 to the power 1/3. So here I'm plugging that and replacing gx by x plus 1 to the power 1/3. And then we have to take another third power that is coming from the f function, and we have minus 1 here, which is in the outside. So now here again the power of a power 1/3 and the power 3 cancels out. Then we get x plus 1 and minus 1. 1 and minus 1 cancels out. Again we get x. So that means this f function and g function satisfies these two conditions for all x's. So that means these two functions are inverses of each other. So that means f is the inverse of g and g is the inverse of f. So now let's move to the graphing of functions and their inverses. The key here is, let's say we have a function f which is a one-to-one function, so that means it is invertible, or in other words we can find an inverse function for f. So let's take the inverse function of f is f to the power minus 1, this notation f inverse, and the graph of this function is the reflection of the graph of f with respect to the line y equals x. So let's look at how we can do that. Here I'm taking my f function to be square root of x minus 1, which is a one-to-one function, so that is invertible. And now I'm drawing the graph. Here we have the graph of this fx function, and this line is the y equals x line, exactly 45 degrees each side here. Now the graph of f inverse of x is nothing but the reflection of this graph about the y equals x line. So that means if we look at this graph, now you can see how it's being reflected. It was somewhere here, now after reflected it is like this. So this is the inverse function. You can find this f inverse of x function explicitly by the switch and solve method we discussed before. So that's the key to draw the graphs of inverses. Now here we're going to do a new thing. Let's say we have a function which is not one-to-one. You know that if it is not one-to-one, then it is not invertible. So that means there's no inverse functions for that function. So, but we can make it to be an inverse one-to-one function by restricting its domain sometimes. Let's look at this function. Here we have our parabolic function x to the power 2. We know that it is not one-to-one in the domain negative infinity to positive infinity. This is the natural domain of this function. We can easily see that if we draw a horizontal line as we did before, it crosses more than one point, it crosses 2 points. So that means this function is not one-to-one. There is not one-to-one in the domain negative infinity to positive infinity if we consider the whole domain. But if we restrict our domain from 0 to infinity, the graph looks like this. It takes only half of that. It's from positive 0 to infinity. Now, if we draw a horizontal line across the graph, you can see it crosses on exactly 1 point. And this is one-to-one now. So what happens here, we didn't do any change into the function, but we changed the domain. We considered only a half of the domain, or we restricted the domain. So in this case, this function is invertible, and you can use the switch and solve method and find the inverse function of this. It is going to be square root of x, and that function is defined for 0 to infinity. You know the domain of this function. Okay, so this is the end of this chapter, and I will upload the videos for the next chapter, chapter 3. Thank you.